There's a storm on Jupiter. It's been raging for over 150 years, maybe longer, possibly 400 years. It's twice the size of Earth. The winds inside hit 400 miles per hour. And here's the thing, it's shrinking, fast. Scientists just discovered it's wobbling like jelly and changing shape every single day. And no one knows if it's going to disappear forever or last another 1,000 years. This is the Great Red Spot, the most famous storm in the solar system. When astronomers first pointed telescopes at Jupiter in the 1600s, they saw something strange, a giant reddish oval sitting in the planet's southern hemisphere. And it was just there, spinning, permanent, unlike anything we'd ever seen. On Earth, the most powerful hurricanes last days, maybe weeks. Then they hit land, lose energy, and die. But Jupiter doesn't have land. It's a gas giant, just clouds, storms, and an endless ocean of liquid hydrogen thousands of miles deep. There's no ground to stop the storm, no friction to slow it down, so it just keeps going. The Great Red Spot is an anticyclone, a high-pressure system that rotates counterclockwise. It sits trapped between two massive jet streams flowing in opposite directions, like a ball caught between two conveyor belts. Those jet streams lock it in place and keep it spinning, year after year, century after century. Let's talk about scale. Right now, the Great Red Spot is about 10,000 miles wide. That's 1.3 times the width of Earth. You could drop our entire planet inside this storm and still have room left over. But here's what's wild. It used to be way bigger. When scientists started measuring it carefully in the late 1800s, the storm was about 25,000 miles across, 3 times wider than Earth, big enough to swallow multiple planets. Since then, it's been shrinking, slowly at first, then faster. By 2004, it was half the size it had been a century earlier. And in the last decade, it's been losing about 580 miles in width every single year. At this rate, it could become circular instead of oval by 2040. Scientists have no idea if this is temporary or permanent. The storm could stabilize. It could keep shrinking until it vanishes completely. Or it might even grow again. No one knows. No one. In 2024, NASA's Hubble Space Telescope watched the Great Red Spot continuously for 90 days straight. And scientists noticed something they'd never seen before. The storm was wobbling, not just drifting slowly across Jupiter's surface like it normally does, but actually changing shape, squeezing, stretching, like a stress ball being squeezed and released over and over again. Amy Simon, a planetary scientist at NASA, said, "We didn't expect to see the size oscillate. This is really the first time we've had the proper imaging to catch it. The storm is definitively squeezing in and out at the same time as it moves faster and slower." No one knows why it's doing this. One theory is that the storm is pushing against those jet streams on either side of it. As it speeds up and slows down in its rotation, it's basically shoving the wind currents around it, and they push back, causing the storm to bulge and contract. But the deeper mystery is this: why is it shrinking at all? Scientists recently figured out something important. The Great Red Spot doesn't just sit there burning its own fuel. It feeds on smaller storms. Jupiter's atmosphere is chaotic, full of smaller white and brown oval storms that form, drift around, and sometimes collide with the Great Red Spot. When those smaller storms get absorbed, they add energy. They make the Great Red Spot stronger, bigger, more powerful. But here's the problem. A team from Yale ran computer simulations and discovered that over the past few decades, fewer small storms have been feeding into the Great Red Spot. Without that constant supply of energy, the storm is slowly starving. It's weakening, and as it weakens, it contracts. It's like a fire that's not getting enough wood. It doesn't go out immediately. It just burns smaller and smaller. One question scientists still can't fully answer: why is it red? The leading theory involves chemistry. Deep inside the storm, powerful updrafts pull gases from far below Jupiter's cloud tops. Gases like ammonia, phosphorus compounds, and sulfur. When those chemicals rise into the upper atmosphere, they get blasted by ultraviolet light from the sun. That radiation breaks them apart and triggers chemical reactions that produce reddish-orange compounds. But here's the thing. The exact recipe is still unknown. Different parts of the storm are different shades of red. The core is sometimes brighter, the edges darker, and it changes over time. Some years the spot looks deep crimson, other years it fades to a pale orange. The storm is constantly recycling material, mixing fresh gases from below with old material from above. It's a living, breathing system that never stops changing. So what happens next? Will the Great Red Spot vanish? Scientists honestly don't know. Some think it could disappear within a few decades. Others believe it might stabilize and last for centuries more, or it could even grow again if conditions change. But one thing is certain, we're witnessing something rare. A storm that has outlived empires, survived longer than any weather system on Earth, and defined Jupiter's appearance for as long as humans have looked up at the sky. Whether it fades away or rages on, the Great Red Spot reminds us that even the most permanent seeming things in the universe are constantly changing. And that storm, twice the size of Earth, is still out there right now, spinning, shrinking, wobbling, and we're watching. Don't forget to like the video and subscribe for more.